Okay, all right. So, any questions on what we've done so far? Is there any examples that I do need to go over?
No. I'm have to start on this one.
Just need a little bit of help on number 7. A 45 100 times 72 equals 45 72.
Which number?
Number 7.
Eight.
So 7 is very similar to what we did yesterday. Um, okay, so is there anything similar in each one of these that we can kind of cancel out? Kind of like how you did yesterday. We had 35 91s, and then we had 35 89s, or 89 35s, 91. Remember that? So we decided, there's 91 groups here, there's 89 groups here. The difference was there was 2 more groups, right? So is there anything in this one that we can do very similar?
There is.
Huh?
2 100s.
Okay, but how are the 100s portrayed on each side? Are they the same on both sides?
No.
Okay,
no.
because this one is a what here on the left side? What's that one? You can see it on your paper there at the bottom. How is the left one portrayed on the left side?
A fraction.
Okay, when you say a fraction, what do you mean a fraction?
The denominator.
The denominator. Okay, how is it portrayed on the right side?
As a whole number.
As a whole number. Okay, so I don't know if we can do that or not. What we need to understand about multiplication is, okay, so this kind of goes back to the philosophy of when we're doing one-step equations, okay? So basically what we're doing is 44 over 100 times 72 over 1 equals 45 over 72 times 100 over 1. What you can do is kind of combine these, okay? So it's 44 times 72 over 100 equals 45 times 100 over 72. Okay? If y'all can't see this, get where you can see. Okay. So, is there anything that we can kind of cancel out? Because what it's saying is the left side equal to the right side?
I mean,
Because this is what the very essence is saying. This is equal to this.
in 100, there's 28 more than 72.
Okay. 28 more what?
Numbers.
Okay. So is the other aspect of the problem the same? Okay. So here on this right here, we have 35s, and we had 89, and then 91 of them. Of course, I would have to sneeze in the video. Okay. Okay. So we're going to progress down this right here. Go ahead and write this down on your papers. Okay. And I'm going to let you kind of challenge yourself to see how far you can go. Now, I would start from the get-go here. Write that down. And then we're multiplying fractions. Everything is a fraction, even a whole number, okay? And then, when you multiply, you just multiply straight across. That's how we got this, okay? So, there's probably, I don't know, depending on how you work it out, probably a couple more steps left. Maybe can get it one more step. Just kind of depends on how the process going forward that you do create. If you need to move, you can move, okay? Yes, ma'am.
That was for like a whole different problem.
Okay, we'll do that. I'm gonna let these copy this down real quick, and then we will go.
I thought that was supposed to be a 45 instead of a 44.
I don't know. I may have looked at it wrong.
Yeah, it's a 45.
Okay, my bad. It's always good to pay attention. Okay, now that changes some things. Does it? Okay, let me know when you got your throat down, because we will do on the next couple of problems.
Okay.
I'm gonna go today and see if I can get one of those little things that instant voice translators. Really.
Can't you use a
I mean, by the end of the year, I'll be speaking Spanish, and y'all be looking at me like, I'll say, get with the program. I'm just wondering how it's going to work. That it hears the sound, comes out something. That's weird, and they ain't really expensive.
Doesn't Alexa do that already?
Huh?
Doesn't Alexa do that already?
Oh, night. Oh, what does Alexa?
No.
Possibly.
I would want to buy one that would do Japanese,
Oh, that'd be cool.
so I could go to Japan.
Well, then that's what they use them for. I mean, it used to be like a book that you used to look in, and then they kind of devolved into these things, so you can instantly interact with people.
It sounds
Yeah.
like it'd be expensive.
Some of them are, some of them not. Okay, all right. So we got that down.
Yes.
Okay, all right. So what's the other one that we need help with? Okay. All right. So we've done basically this all year long. We maybe not have had the same terms, but same process. Okay. So we got to find the greatest common factor. We're going to factor this out because the question asks us 2 different ways to rewrite this using distributed property. Okay. So we're used to maybe a number and a variable, okay, and not necessarily a number and 2 variables, whatever. So we know how, like, say, if we had 6 and 9, how we had to find the factors, right, from the old days, right? All right, not really old days. So now what all you're doing, you're factoring 3xy and 6yz. Now, this is how you do it, okay, in algebra, okay? You factor the numerical part first, and then we're going to do the variable part later, the letters, okay? What are the factors of 3? What are the factors, not multiples, factors. Yeah, factors.
1 and 3.
1 and 3. What are the factors of the variables that we have? X and Y, okay? Now, factors of 6.
3 and 6.
Mm,
And 1.
1 and 6.
1 and 6.
2 and 3.
2 and 3.
Oh, my bad.
And then, what are the variables?
Y and Z.
Y and Z. Now, this is how you do it. You pick the numerical value, and if there's any variable value, okay, you go from left to right, okay? Is there any numeric value that is the same?
3.
What'd you say?
1.
Well, you start with 1, but is there any other number that's the same?
3.
3. Okay, so 3. Is there any variable that's the same?
Y.
Y. So your greatest common factor is 3y. You set it out to the left of it. This is what I recommend when you first start. Anyways. See how this term is right there? Put a blank under it. See with a plus sign. Put that under it. Where that term is there, put a blank. Close your parentheses. Now, boys, I don't know what y'all are doing over there, but you need to be a little bit quieter, please. If I took a 3 and a y out of this, what do I have left? If I took a 3 and a y, what do I have left?
X.
Okay, maybe that's what you need to do. Okay, can't really do it this next one. Okay, if I took a 3 out of the 6, what do I have left?
3.
So how many times will 3 go into 6?
2.
Okay, so 6 divided by 3 is 2. I just can't say go into for Spanish because it doesn't translate good. Now, so that's out, that's out. If I take a y out, what do I have left?
Z.
Z. Okay, now, you still got to have that. That's just for a visual. This is another way to write this. On the distributed property, how we would multiply everything on the inside, everything on the outside times everything on the inside. Here we're doing it backwards. We're going the other way. If you'll notice on the one-step equations, we saw multiplication by division and so on and so forth. Math solves itself by doing the opposite. So if the distributed property is already here, we have to factor it out. What we've been doing is having it like this and doing the distributed property. Factoring is undoing the distributed property. Okay? That makes sense. So that's one way. It says write 2 ways. That's one of them, so y'all have to do one more. With your brain.
I don't have a brain.
Yes, you do.
I do.
What else? So the front side's pretty easy, okay?
I already done
There's only three.
Huh?
There's only 3 and 6. So what else numbers am I supposed to see a different one?
It's a different way.
I know. Can I just like flip those around? Okay.
I didn't say yes, I didn't say no. I'm just saying. Is there anything else that we need help with?
No. 9.
There is no 9 on there.
9.
There's only 7.
Like no, German.
Oh, you're saying that's none?
Yes.
9 means 9 to me.
Yeah.
9, but E.
9, like,
And
Okay.
then
The E's.
Okay.
Okay, just
All right.
before that.
Anything else that we need?
Shut up. Great. Not one.
Okay. Anything?
bigger.
That one. That one.
Okay. So, I'm gonna